All right, we continue from where we stopped. We have a couple of things to finish up with. I want to find out if the network is clear now. Do we have, is it clear at the moment? All right, let's try and finish up with this particular question. So we have this function, and we're told to find the composite function of this, f of x being the parent function. All right, how do we do that? I still want us to solve the question of binomial expansion, very, very important. And I have my g of t as this, all right? I want to find f g of t. What do I go on to do? Wherever I see t, I'm going to be fixing g of t there. So I'm going to have, in this case, I'm going to be having, instead of t now, I'll be having square root of 3t minus 1. Of course, I'll be squaring this plus 1. This is the function fg of t. This will be, of course, this will cancel this, I'll be left with 3t minus 1 plus 1. And this gives me a value of what? 3t. So you can see how easy it is to solve and to excel in A-level mathematics. These are the questions that have been asked of students, and I really believe at this point, all these questions should be easy peasy for everyone in this class. All right, I hope to solve two particular questions on binomial expansion, and we close up for the night. The very first question said, in the binomial expansion of 1 plus kx raised to the power of 6, what you are asked to find the value of k here, and you're told that the coefficient of, all right, let me read the whole question and you can get the hang of it. In the binomial expansion of 1 plus kx raised to the power 6, where k is constant, the coefficient of x cubed is twice as large as the coefficient of x squared. Find the value of k. Find the value of k. In the binomial expansion of 1 plus kx raised to the power of 6, k is a constant. The coefficient of x cubed is twice as large as the coefficient of x squared. Find the value of k. How do you solve this? How do you solve this particular question? Look at the detail that was given. Coefficient of x cubed is twice as large as the coefficient of x squared. This means you could easily write a new expression that will give you your value of k. But before we do that, can we go on to solve for the expansion of this? I'm sure you can all solve this. I don't want us to waste time expanding this because I know you all know how to expand this. When you expand this particular expression, you get a value of 1 plus 6kx plus 15k square x square plus 20k cube x cube and on and on and on. All right. The coefficient of x cube is twice as large as the coefficient of x squared. Can you write that mathematically? What are you going to get? Of course, this is the coefficient of x cube right here. They said this coefficient of x cube is twice that of x squared. The meaning of this mathematically is that we're saying 20k raised to the power 3 is equals to 2 times 15k squared. You can see what's going on here. The condition given was that the coefficient of x cube is twice as large as the coefficient of x squared. Now, this is the coefficient of x cube. This is the coefficient of x squared. If you're going to write this mathematically, you have to write it like this. Because when you say the coefficient of x cube is twice, that means the coefficient of x cube is 2 times the coefficient of x squared. This is the way you write it mathematically. And what you get here is that you will get this as 20k cube is equals to 30k squared. We keep on solving this. Of course, we can bring all of them to one side. We can factorize 10k squared out here. We're left with 2k minus 3 equals to 0. Of course, from what you have here, you won't be wrong if you write 2k minus 3 equals to 0, or of course the other one is not very vital because you'll be getting 0 there. So I'll just focus on this. 2k equals to 3 and my k equals to 3 over 2. That is how you get the value of k. Can you see how simple this is? This is one of the questions that I thought to show you so that you are very versatile when it comes to binomial expansion. We have another question on binomial expansion. This one came out last year. And I need you to pay real attention to this question we want to solve on binomial expansion. It came out last year and it carried a total of 6 marks. Question type MSA 011. MSA 011. Now look at the question. The question looks very simple, but when you try to use your calculator is where you're going to have you are going to need a lot of technicality. This was the question. The binomial expansion was this: x minus 1 over 2 raised to the power of 6. You are told to write down in its simplest form the complete expansion of x minus 1 over 2 raised to the power of 6. Write down in its simplest form a complete expansion of x minus 1 over 2 raised to the power of 6. Can you take your time to do that very quickly and tell me what you got? Is the question number 2 that I really want to focus on. You will need to use your calculator in a very smart way. The question said you should write down in its simplest form, or probably we should do it for those of you that are struggling with binomial expansion. Probably we'll try and solve this question ourselves. But I'm thinking by now everyone should be versatile in expanding using binomial expansion. All right, let's not assume. Let's just try and solve this and let's see how we go with this. All right, if you're going to expand this, what are you going to do? All right, so we have our general binomial expansion is given by n combination k. Of course, if we had a plus b raised to power n, the binomial expansion is giving us n combination k, a raised to the power of n minus k, and b raised to power k. All right, I'm sure we all know this. So given this question, I believe everyone should be able to solve it quite easily. We're given x minus 1 over 2 raised to the power of 6. So all you need to do is just to, and you are told, the one thing you need to pay attention to is that you are told to write down in its simplest form. This means you're not supposed to leave any stone unturned while writing the final answer. You have to write down in its simplest form every of the terms of this binomial expansion. So I'm sure you guys are working at the moment. So I will keep doing my own here, and then let's see what our final answers will be. So we have this expression. Of course, when we have x minus 1 over 2 raised to power 6, what we'll be having is we'll be dealing with 6 combination k, and our x raised to the power of 6 minus k, and then minus 1 over 2, the second term, raised to the power of k. In this particular case now, we will go on with increasing our k value from 0 up till n. So we have this as 6 combination 0, x raised to the power of 6 minus 0, minus 1 over 2 raised to the power of 0, plus 6 combination 1, x raised to the power of 6 minus 1, minus 1 over 2 raised to the power 1. Of course, I'm not going to complete this. I'm just going to show you the pattern, plus on and on and on, plus the final one will be 6 combination 6, then x raised to the power of 6 minus 6, then minus 1 over 2 raised to the power of 6. All right? So this is what we have for our binomial expansion. And if you go on to solve this, your very first term, because don't forget you are told to solve this in its simplest term, so you are expected to bring out every of the terms of this particular binomial expansion without leaving anyone completely solved. So one of the first things you will see is that your very first term will be 1 x raised to the power 6 times 1 plus 6 x raised to the power 5 minus 1 over 2 plus 15 x raised to the power 4 1 over 4, then plus 20 x raised to the power 3 minus 1 over 8, then plus 15 x squared 1 over 16. Then the last term will be plus 6 raised to the power, not the last term, x raised to the power 1, then minus 1 over 32. Then we have plus 1, then 1 over 64. So this is some of the terms you will get. I'm sure you guys should be able to relate to this while solving. Now your final term will be x raised to the power 6 minus 3x raised to the power 5 plus 15 over 4 raised to the power x raised to the power of 4 minus 5 over 2 x raised to the power of 3 plus 15 over 16 x raised to the power of 2 minus 3 over 16x plus 1 over 64. So this is the final term. So if you are able to get this answer based on the question that was asked last year, you will get a total of 3 marks. Now, the last question there, which completed the 6 marks for this question, goes for about 3 marks. And this was the question that was asked. Pay attention, please. Now, they decided not to test you with bringing out the x value yourself, but they said by taking x equals to 1 over 400, show that by taking x equals to 1 over 400, by taking x equals to 1 over 400, show that minus 199, show that minus 199 over 400 raised to the power of 6 is equals to 0.01516. Study this carefully and let me know if you understand how this question goes. They said you should take x. The question said by taking x equals to 1 over 400, you should show that this particular expression, minus 199 over 400 raised to the power 6, is equals to this. Now let me submit to you quickly that without you being given the value of x being 1 over 400, you can actually get this 1 over 400 yourself. Probably we try and solve that so that in case you were not even told that x was 1 over 400, so you don't get confused, because this particular question was quite buoyant in terms of trying to help students to have a pathway towards a solution. But this may not be like this all the time. You may have a situation where you won't be told the value of x. So let's try and tackle it from that angle first before we then go on to find or prove what we're told to prove. So if we're not given the value of x being 400, even though we were given this in this particular case, how do we solve this particular question? Now look at it. We have minus 199 over 400. Don't forget our initial expression was x minus 1 over 2 raised to the power of 6. So if you are seeing this and you were not told this, let's imagine you were not told that x was equals to 1 over 400. How do you get your x value? Of course, if you were told to get the answer for minus 199 over 400, what do you have to do? Well, you have to go on to say x minus 1 over 2 is equals to minus 199 over 400. Of course, you will take the values here, equate it with the values here. From here, you'll be able to get your x value that will fit into this expression that will give you this value. So if you go on to solve this, you will have your x being equals to minus 199 over 400 plus 1 over 2. Can you try and press this on the calculator and tell me what your value would be? If you try and press minus 199 over 400 plus 1 over 2, what does it give you as a value for x? Anybody with an answer there? Minus 199 over 400 plus 1 over 2. Thank you very much. Somebody has gotten an answer. The value is 1 over 400. So you can see that it's not necessary you get this particular answer being given for your x. If you're not given, you should still be able to get your final answer. And your final answer, in this case, will be 1 over 400, which tallies with what you were given. Now, this is the meat of this particular question. You were then told to show that this particular expression is equals to this. That means they're telling you to fix in 1 over 400 into this box. All right. It looks very simple while you're seeing what you're doing. But when you decide to start this work, can anybody there try to fix in x being 1 over 400 into the expression? This was the expression we got for x minus 1 over 2 raised to the power 6. Don't forget, this was our binomial expansion here. What we have here, what we have down here, this was the binomial expansion we got when we expanded this. Good. Go and fix x being 1 over 400 into this expression and see how easy it is to solve. I want you to start fixing that in quickly. Put in x as 1 over 400. Of course, that means in this case now, you put in 1 over 400 raised to the power 6, and you try that and see what your value is. Put in 1 over 400 raised to the power 5. Put in 1 over 400 raised to the power 4. What values are you getting and how nice are they? So this was why I said we need to talk about this, because it's quite very, and this was last year question. So you see that there's no way, this is not a unrealistic question. It's a question that came out last year. So people had to face this in an exam hall. So I want to show to you how to solve this in such a way that you'll be able to prove this expression, even though you have a lot of big values. So can anybody do that quickly? What's 1 over 400 raised to the power 6? What do you get on your calculator? I'm sure if you have a calculator right there, you will be seeing a value of 2.44 times 10 raised to the power minus 16. 2.44 times 10 raised to the power minus 16. That's a super large value. 2.44 times 10 raised to the power minus 16. Now, if you go on to press for 1 over 400 raised to the power of 5, you'll be getting 9.76 times 10 raised to the power minus 14. Now, how do you solve using all these values? How do you solve using all these values? Well, what I'm going to tell you is, if you can really pay attention, let me show you right on this place how to solve this, because the fact that this came out last year makes it very amazing, and why I really want you to have a way of going around it. All right. Now try and fix in your value for x being. Now what you're going to do is you're going to write out all the values you got initially. Try and leave your answer in 4-figure, and you'll see the way you're going to have to manipulate it. You have to be very smart, and you have to be very patient. You need patience to be able to get through this particular work. Now, the very first value you have there is 1 over 400 raised to the power 6. And what you're supposed to get is, if you press that on the calculator, that will give you write that down in your notes. And if you do the next one, 1 over 400 raised to the power 5, what you're going to be getting is another large value. What you're going to do there is multiply by the 3, by this 3. So you have 9.7656 times 10 raised to the power minus 14, minus, when you multiply the value you got when you fixed in x as 1 over 400 raised to the power 5 times 3, you're getting a value of 2.9297 times 10 raised to the power minus 13. Then you go on to doing the next one. Of course, x raised to the power 4, that's 1 over 400 raised to the power 4. Multiply it by 15 over 4. You do that also, you should get a value of 1.4648 times 10 raised to the power minus 10. If you do the next one, x raised to the power 3, put in x as 1 over 400, and after getting your value, multiply it with 5 over 2. You'll be getting minus 3.9063 times 10 raised to the power minus 8. You put in the next one, that's for x raised to the power 2, then multiply the answer times 15 over 16. You get a value of 5.8594 times 10 raised to the power minus 6. We do for the next one, which is just x. That's 1 over 400 multiplied by 3 over 16. You'll be getting a value of minus 4.6875 times 10 raised to power minus 4. And the very final one here is just the 1 over 64, which is just 1 over 64. Which one are you correcting? The first one. Yeah, this is why I'm trying to. One over 400 divided by, sorry, 1 divided by 400 raised to the power of 6. What did you get there? Oh, 2.44. Okay, I can see that there. Just hold on, please. Okay. I see what happened, what I did here. What I did was I used this particular value. Okay. All right. Yeah, you're actually very correct. What you're saying is correct. But what I'm trying to do here, which is what I want to teach you, is that I found a way to dissolve all of these things in such a way that I can easily make use of my calculator without having any issues. That was what I did there. That value you're seeing there is not the exact value for 1 over 400 raised to the power 6. So if you sit down with this carefully and you find a way to, what the major thing here is for you to not, you don't have to solve it straight up. You have to find a way to attach them to each other in such a way that when you press it on your calculator, you'll be getting smaller values. So then at the final instance, this was actually what I got, which I've done some manipulations. Probably I'll tell you that later. Let me just go on to tell you the way, I will tell you the way I manipulated this probably later. But then when I got here, one of the next thing I did was to then, I decided to group them. So I grouped them in this way. I can see that everything from this place to this place has a 10 raised to the power of something. So I grouped them. I left the 1 over 64 outside. And then what I went on to do was I went on to bring out 10 raised to the power minus 4. So I brought out 10 raised to the power minus 4. Don't worry about this particular value. I've done something to it that made it like this. I can find a way to explain that very soon. So I brought out 10 raised to the power minus 4. Then I obviously will be left with 9.7656 times 10 raised to the power minus 10. Then minus 2.9297 times 10 raised to the power minus 9. Then we have plus 1.4648 times 10 raised to the power minus 6. Then minus 3.9063 times 10 raised to the power. Sorry, this is supposed to be minus 10. This is supposed to be minus 13. Sorry, this is minus 6. This is, okay, minus 9, minus 6. All right, this is going to be minus 4. I think I'm on point. Minus 4. And then I have plus 5.85. This could be you in the exam hall, by the way, last year. If you were in the exam hall last year, this could be you trying to do all this. Times 10 raised to the power minus 2. And the final one, which was this, of course, it had a whole of 10 raised to the power minus 4. So it will be left with just the value alone. So minus 4.6875. This was the end of that bracket, and I have to remember my plus 1 over 64. So you can see what has happened here. I've been able to make my work a little bit less complex than it was initially. Of course, still a bit complex, but a little bit less complex than the initial stage. This is the way, because your calculator may not be able to handle all of this. And don't forget, it's a proof. So you're not going to just press this on the calculator and just say the answer. You were told to prove it. The question said, by taking this, show that this was equal. So you have to show it, obviously. You have to show it. And it's carried a total of 3 marks. So you know the importance of making all this very clear to the examiner. Now, if you go on to solve this was what I then did. Now I can see values that are much smaller than, I can press this on the calculator easily. And then I can do this minus this. This would be obviously 0.058594. So I can press it on the calculator, then subtract it from this. Then after I do that, then I'll get a value. Then the value, I will have a value there. Then I will take this, which will be this will be 0.000403963, and add it with this. So the way I did this was, I kept on breaking it down in bits. I kept on breaking it down in bits till I was finally able to arrive at a final answer. I believe, just for the sake of those of you interested, because I don't think I want to show you all my notes at this point. Let me just tell you, I arrived at a place where I think I got to 10 raised to the power minus 4, and all that was in the bracket, I was able to dissolve it to minus 4.629295.167. I always tell you, personally, I always love to preserve my decimals because I don't want to lose a chunk of the figures are still with it. So, and I think when I press this on the calculator, I don't know, can you try and press what I just wrote, and let's see, 0.0001 multiplied by 4.629295.167. Then that value you get, then you have 1 over 64 minus that answer. Yes, of course. If you do this particular thing I wrote here in a calculator, this was the final step. Of course, I told you I've done some other things before this. I just, I don't want to have to show all those. So when you press all this into a calculator, I got the final answer to be 0.01516, which was what they told me to show that particular thing was equals to. I think somebody is saying something about 1 over 64 or thereabout, be 1 over 6 or something. Again, I told you already, I already did something to this particular thing you are seeing, this 9.7656. I believe I already used it with something else. So it's actually very correct. What you have on the board is very, very correct, but I already used it with something else. It's not standing alone. So it's possible. I'm going to show you what I did now. I told you I was going to show you, so just hold on. Let me show you. So this is how we're able to get all this solved. Okay. All right. How many of you enjoyed this particular question? This is I saw this last year. This I saw this in the question last year, and I felt like we needed to talk about it so that uh, you are very much aware of the fact that this is a very likely question. It came out last year, so it could have been you solving this. Yeah, yeah, it's actually tedious. Yeah, but this is something you have to, yeah, to Kuma. So exactly, it's something that you could have to face. So that's why we have to also prepare for it also because you cannot tell where questions will be administered from. So this is how, yeah, you see, the point is, I'm very sure these steps you have in front of you is very correct. The only point is, I know while trying to solve one of the things I was aiming at. So this particular first thing you are saying here, whatever we have done something which I did not write the steps down, so I may not. I because I was trying to find a way to use the calculator to hold out all these values in such a way that I can easily um, use them. So that's what you saw here. This is the step before here. I didn't talk about it, but I just had this somewhere after pressing on my calculator and trying to find a way to align them with each other. I was able to arrive at this particular expression. So it's very correct. Obviously, you can see that the the answer we have aligns with the answer that we're told to get. If somebody is saying, will this question be expected to solve? No, you may not solve this particular one in 1 minute. Of course, that's why you have to learn how to apportion your time well in an exam or yeah, this is actually again, this was the question type was you can go how to find it. This is question type MSA 011. This is actually the very first question. The very first question, look at it in case you want to see it. The very first question, and it's it's the very first question somebody had to meet last year. So you could also you could have been the one in front of this. Is it not better for you to be solving this in a practice section rather than in an exam hall? And you would have to you would have to compete for your mark, so you wouldn't want to leave it alone. So this is essentially how you prepare for exams. You could some questions are very easy while some will take your time. So you have to solve the easy ones. Uh, you have to solve the easy ones quickly so that you have more time for complex ones like this. This is not actually complex. The major thing here is that it has large values of numbers 0.00. Look at 10 raised to the power minus 14. So you have to be very diligent. And you see, that was what I was trying to do here in expressing minus 4 out. Now, one other thing I will try and research on is if there is a quicker way or a much more less cumbersome way to solve this. So this is actually so I that was why I factorized 10 raised to the power minus 4 out. This was an effort to reduce the volume of the power here. So I brought this out and then you can see it's still here. So when I was able to use the calculator to express all this, then I arrived at an answer of this. Then I was able to now multiply this with the 10 raised to the power minus 4 that I had factorized outside. Then the value I got there, I added it with 1 over 64. And this is how I got the answer. Now, there's a very big delicacy of this. If you get a wrong decimal somewhere, probably you made a mistake. Can you imagine solving all this and you made a mistake in one of the decimals here? And when you did your final solution, you didn't get 0.01516. That means all the time you spent in doing that would have been wasted because you needed to arrive at this answer. That was the clause given here. You have to get this answer. So if you made a mistake in any of the decimals, or probably you changed terrestrial something to something else, you'll be getting a wrong answer here. And if it's not correct, you'll be missing all the marks in that particular question. So this is why I advise you to always solve questions very carefully. Be very careful when you're solving questions. Make sure you're not too much in haste, especially when you're solving questions like this. And always express your decimals well. You don't want to be approximating this as 5.9. Yeah, that would be so wrong. You don't want to be approximating this as 3.9. Can you see that these values here are quite small? 0.01516. And don't forget, the question said you should prove that that was equals to this particular value. So if you went on to get something else, I hope you know that that will not do. So if you got 0.014, for instance, I'm sure you know that that's not going to be okay. So you have to be very careful. So guys, this question happened this way, and again, this is last year, so you have to pay attention to what you're doing. We have to leave this class at this point. I think we've done right. I think we have done well. I think we have done well this weekend. This is, of course, the end of this particular weekend's tutorial. We'll be seeing again next week. I hope to see you guys next week. Thank you guys. Do well to sleep well. Enjoy the night. All right, guys. Take care of yourself. Take care of yourself. It's good night here. Good night. Take care of yourself.